Hey everybody, happy Friday. Welcome to Earth Science. So, if you remember on Tuesday, we took a look at this new piece of misinformation from Marco Rubio. That claim that, the climate's always changing. We don't have evidence to say that humans are causing it. And if humans aren't causing it, why should we be worried? And so, first, I want to say, in looking at your first attempt at disproving that, I was really impressed with the high quality responses and evidence you already had. However, a lot of you came up with the great idea that in order to disprove that, it would be really helpful to know more about what does cause climate change and build up that science background knowledge like we did with the last claim. And that's exactly what we're going to do. We're going to spend the next couple days looking at what does cause climate change, and then we're going to go back to revisit that claim armed with our new science knowledge and see if we can hit that BS button on it. So let's get started looking at what causes climate change. Okay, so the main thing we're going to be looking at today is something called greenhouse gases. Now, that's something I'm sure you've heard that name before, but what do you know about greenhouse gases? So here's what they really are, to put it simply. It's just any gas that traps heat in the atmosphere. So, and when I say the atmosphere, I'm just talking about the air. So the air you're breathing right now is part of the atmosphere. The air miles up in the sky that planes are flying through, that's still the atmosphere. And if you want to put something into the atmosphere, you just put it into the air. For example, right here I have a lit candle. But if I blow it out, you see we get all this smoke. This smoke is entering the atmosphere. It's becoming part of the atmosphere. So that's all the atmosphere is, the air around us. And greenhouse gases trap extra heat in the atmosphere. And there are a bunch of different types of greenhouse gases. Do you know any examples of greenhouse gases? So the one I'm guessing a lot of you knew was carbon dioxide, or CO2. Of all the ones we talk about, that is the main, most important one, and carbon dioxide is the one that plays the biggest part of climate change. There are other ones too, such as methane, also known as CH4, nitrous oxide, known as NO2, and chlorofluorocarbons, which we call CFCs for short. Now, even though all those gases are different and have different effects, they're all considered greenhouse gases because they trap heat in the atmosphere. So now let's take a look at where do they come from. So for now, we're only going to be focusing on carbon dioxide since that's the main greenhouse gas. The other ones will have different places they come from, but we're not going to worry about that now. So when we're looking at where the greenhouse gas carbon dioxide comes from, we're going to look at this thing called the carbon cycle. The carbon cycle is just how carbon moves in and out of the environment. And so here's a picture of it. And so when you look at it, you'll see some arrows are going up into the atmosphere. That would be adding carbon dioxide. Other arrows are coming down and going into the ground. That would be taking carbon dioxide out of the atmosphere. So what do you see is putting carbon dioxide into the atmosphere? Yeah, so here we see a couple things. First, we see plant and animal respiration, and that's just cellular respiration that we learned about in Living Environment last year. So anytime you do cellular respiration and breathe out, that's putting carbon dioxide into the atmosphere. You can also see off to the side, there's that factory and the smoke coming out of it. A lot of factories and industrial things like that will put carbon dioxide into the air. But then you also see the tree takes it out because of photosynthesis. That's why plants are a great way to combat climate change, because they remove carbon dioxide. But then you also see on the very bottom, it says fossils and fossil fuels. Now, fossil fuels are a really important thing when it comes to greenhouse gases. Do you know what a fossil fuel is? So, a fossil fuel is any natural fuel that we get energy from by burning it. That's important. You got to burn it. And so, some examples would be like oil, coal, or natural gas. And if you ever wonder where they come from, here's a quick video to show you where fossil fuels come from.
Approximately 360 to 286 million years ago, even before the age of dinosaurs. At that time, the land was covered with swamps filled with organisms and plants. As they died, they sank to the bottom of swamps and oceans and over millions of years started decomposing under layers of sand, clay, and other minerals. Different types of fossil fuels formed depending on the combination of organic matter, temperature, time, and pressure conditions while decomposing. There are three major types of fossil fuels: coal, oil, and natural gas. Coal was formed from ferns, plants, and trees, which hardened due to pressure and heat. Oil was formed from small organisms like zooplankton and algae, where pressure caused the more complex organic matter to decompose. Natural gas was formed by the same process as oil, only it was exposed to more heat and pressure, causing it to further decompose and turn into a gaseous form.
Alright, so to recap, the important thing with fossil fuels is that anytime we burn them to get energy, which you do every time you drive a car or anytime you have a factory that runs on coal, you're burning that fossil fuel, and when you burn it, you're getting a lot of carbon dioxide entering the air. So that's a very important source of carbon dioxide and greenhouse gases, is burning fossil fuels. So now we know kind of what a greenhouse gas is. We know where carbon dioxide comes from, but why does it cause climate change or global warming? Let's take a look. So the last thing we're going to talk about today is something called the greenhouse effect. And it's called the greenhouse effect because it's named after what happens in a greenhouse. If you don't know what a greenhouse is, they look like that, and they're just buildings made of mostly glass. And what they do is they're able to simulate an artificial climate inside that would allow plants to grow in a place they normally wouldn't. So, for example, if you tried to grow a cactus in New York, it'd probably die in the winter when it gets way too cold. However, if you have a greenhouse, you can basically create that hot, arid climate that the cactus is used to, and it'll survive just fine. So you may be wondering, well, how does just putting glass on a building make it hot? Well, it's the greenhouse effect. And to shake it up a little bit, rather than me tell you how it works, I'm going to turn it over to Bill Nye the Science Guy.
The atmosphere keeps the Earth warm in kind of the same way this jacket keeps me warm. Now, when an atmosphere keeps a planet warm, we call it the greenhouse effect. It's the same thing that keeps this greenhouse warm. It works like this. A greenhouse is covered with layers of glass. Light from the sun, the light that we can see, what we call visible light, goes right through it. It hits the plants growing inside and is given off as heat. Now, the heat doesn't go right through the glass. No, it's reflected back inside. It's bounced back in. And that's what keeps a greenhouse warm. The same thing happens on the Earth. But instead of a layer of glass, there's a layer of air, the atmosphere. So light from the sun goes right through the atmosphere, it hits the Earth's surface, and is given off as heat. The atmosphere holds the heat in. Now, without the Earth's atmosphere, the Earth would be very, very cold at night and very hot during the day. The atmosphere keeps everything kind of even and nice here. It's the greenhouse effect. You can see it. Oh.
So to sum that up quickly, a greenhouse stays hot because it traps the heat from the sun. And our atmosphere can do the same thing. It traps the heat from the sun, which makes Earth warm. If we didn't have any greenhouse effect, the Earth would be freezing cold and we would all die. So, in a way, the greenhouse effect is a good thing because it makes the planet warm and allows us to live in it. But here's the problem. The problem comes with adding extra greenhouse gases than what the planet is used to. So what do you think adding more greenhouse gases are going to do to the greenhouse effect? Yeah, that's it. Greenhouse gases increase the greenhouse effect. So it'll be trapping extra heat and making the planet extra hot. And that's where global warming is coming from. Greenhouse gases causing an even bigger greenhouse effect and causing even more heat to get trapped in the atmosphere and warm up the planet. So that is the cause of climate change. So now let's real quick take 30 seconds, sum up what we did today, and then we'll wrap up. So, quick summary. First, greenhouse gases are any gas that traps heat in the atmosphere. The atmosphere is just the air all around us. And this one right here, carbon dioxide, that's the main, most important one. All the others are bad, but carbon dioxide is the biggest effect. Next, carbon cycle. This is where carbon dioxide can both enter and exit the atmosphere. So it enters the atmosphere via animal and plant respiration and burning fossil fuels. And then photosynthesis from plants is one of the few things that will take it out of the atmosphere. So plants help with climate change. Lastly, the greenhouse effect is just trapping heat in the atmosphere from the sun, which you can see right here. However, greenhouse gases increase the greenhouse effect and trap too much heat, which makes it too hot. All right, that's it for today. Let's wrap up real quick. All right, everybody, that wraps us up for today. Just two quick announcements before we go. Number one, the assignment today involves some graph reading in addition to what we've been talking about. So if you need a little extra help with reading graphs, there's going to be an optional video at the end of this, and it's also linked in the assignment if you need it. And then number two, remember next week has a different schedule. So because of Memorial Day, you don't have class Monday and Tuesday. Then Wednesday and Thursday are going to be like a Monday and a Tuesday. So all your Monday classes will be on Wednesday. All your Tuesday classes, including Earth Science, will be on Thursday. And then Friday is Career Day. So if you need any help with that, just email your advisor or me. I can help you out. But until then, have a great long weekend. See you next week, everybody.